So welcome everyone to the Building Integrated Photovoltaics meeting that we have today with Associate Professor Dr. Rebecca Yang. I would like to begin this meeting by acknowledging the traditional owners of the land from where I'm sitting here today, the Wurundjeri people, and pay my respects to their elders, past and present, and Aboriginal elders from other communities who may be here today. The event is brought to you by IBIPSA, International Building Performance Simulation Association, on the Australasia chapter. IBIPSA is a non-profit international society of building performance simulation researchers, developers, and practitioners that are dedicated to improving the building environment. The mission of IBIPSA is to advance and promote the science of building simulation in order to improve the design, construction, operation, and maintenance of new and existing buildings. We do this by facilitating the exchange of information, engaging educational initiatives, sponsoring research, and forming alliances with diverse organizations. I am Pamela Chicon, your host today, and I'm a sustainability consultant with NDY, and I'm also part of the events committee here in IBIPSA. So welcome everyone, very excited to be here. If you would like to know a bit more about IBIPSA, please join us in our online platforms, LinkedIn or our website. Today we'll have the honor to talk with Dr. Rebecca Yang. She is the leader of Solar Energy Application Lab from the School of Property Construction and Project Management from RMIT University. Here you are, Rebecca. Rebecca is a building and construction scholar working in the subfield of innovation adoption. Her area of expertise is applied distributed renewable energy, and she is particularly known for her research on solar building envelope applications, which has led to over 100 publications. So we're very glad to have you here. Thanks for joining us. Part of IBIPSA's other events that are coming up, we are collaborating with different partners, so keep in touch in our online platforms and we'll get going with more events. And I'm handing over to you, Rebecca. Just one more housekeeping item. If anyone has any questions throughout the presentation, please write them in the chat. Rebecca's team will be able to respond to these questions. And at the end, if we have time, we'll join into a live Q&A session. So stay tuned. Thanks.
Thank you so much, Camila. And thank you, IBIPSA, to provide this opportunity to talk about our work. And thank you for all the participants who come to this event. It's really great to see the interest from industry on BIPV, which I haven't seen for some time previously. So today we will talk about BIPV Design 2. We have been funded by ARENA and RMIT. That's called BIPV Enabler. It's developed by our lab, Solar Energy Application Lab at RMIT. And in partnership with some industry partners in Australia and overseas. And all the information from today's presentation will remain the copyright at our lab. So let me, Camila, could you please go to the next page? Yes, so that's our lab page. If you search RMIT SEAL, you will find it out. Basically, we support solar energy application in buildings and urban level. We do a lot of simulation, assessment, geospatial mapping, modeling, etc., to facilitate decision making and policy development. On top of that, we represent Australia in the International Energy Agency (PVPS) task specifically on BIPV. We lead some activities and theme, and we draw into a lot of activities there. And we also represent Australia in the IASHC task on solar energy buildings. On top of that, we also represent Australia in the joint working group for standardization, referring to BIPV between two tasks under IEC and ISO. And we are developing some BIPV specific standards internationally. Please, next. So today we organize this as part of the knowledge sharing process. We think we take this responsibility in Australia to share the information about BIPV to industry professionals and also provide an overview of our platform. We also want to let you know we will have some physical trial sessions in the near future, and this is basically a preparation event for us as well. Thank you. Next. So let's start with some background. As we all know, building sector consume a lot of energy, and both in Australia, globally, and with national level or state level, there are a lot of emission reduction targets. And in order to do that in the building sector, we engage a lot of distributed renewable energy technologies, especially for the rooftop attached PV, as you can see on the bottom left of the screen. However, BIPV is different from the rooftop attached PV because it functions as a PV module as well as a construction product to serve dual purpose. That's why it's a product which should satisfy the PV requirements as well as the building regulations. Next, please. So globally in the market, there are different products presented to the market in different colors, transparency, texture, etc., with different integration systems. I think the message is very important, especially for the building sector in Australia, to know this, and so that they can select the right product for their project. In terms of the project itself, globally, there are a lot of projects have been developed, not only in Europe in the last 10 years also, but now we see the changes, a lot of changes happening in China, I can say, but in the meanwhile, some other countries such as North America, Canada, Singapore, including Australia, there are a lot of changes in this area in the last 2 years also. For the application sides, BIPV can be used on the rooftop and to replace, say, roof tiles, roof shades, skylights, and it can also be used on the building facade to replace curtain wall, rain screen facade, spanner panel, etc. It can be used as shading device as well to replace carport roof, etc. So there are a lot of application potentials to replace the building envelope elements. There are already successful cases globally to demonstrate that. Next, please. In terms of the categorization, the most accepted one up to now is under the IEC 63092 standard. We propose 5 categories. The first 2 categories are all related to roof, but with the differences whether we could access to the BIPV product from inside of the building or not. And the next 2 categories are about the facade application, again, depending on whether we can access from inside of the building. And the last category is about the external integrated, such as shading device. Next, please. Globally, there are a lot of estimations or forecast regarding the growth market in BIPV. And because I have been involved into this area for almost 10 years, and I can tell you in the first few years, nobody really interested in this area because of lots of reasons. However, in the last 2 years also, the whole industry attitude, especially from the building side, is changing. That's why that makes a lot of impact to the PV industry, and global leading PV manufacturers, they developing a lot of new BIPV products in the last 2 years as well. Next, please. In the meanwhile, we do understand there are a lot of resistance on BIPV. A key problem is on the economic viability. So that's why we want to understand whether BIPV is feasible or not, apart from the technical side. So within our team, we did we collected a lot of global BIPV existing projects, 45 at this date when we published this publication. However, now we have more cases and there are more cases coming. They did some analysis on there. As you can see, it covered different technologies and all the products were developed in the last decade. We had looked at the LCOE value, Camilla, next please, and as well as the MPV per kilowatt. So from our understanding is that if we consider the benefit that BIPV actually replace conventional building material, envelope material, if we consider that benefit, a lot of cases actually can show a good economic value from that. But it also shows that depending on the technology, location, a lot of factors can impact the economic performance of BIPV project. That make more sense for building designers really to understand for individual buildings in relation to a certain product, BIPV product, whether it is feasible to be used. Because every building, as we can see, every building is different. Yes, next please. So, however, although globally there are lots of products have been developed previously or are being developed recently, I also need to remind you that the charts we showed on the last slide are the projects were developed in the last decade, but basically they completed the project back to 3-4 years ago. But within these recent 3 years, there are a lot of new products with good value for money have been developed as well. However, currently in Australia, if we look into some data, we would identify that in between 2014 and 2019, less than 2 megawatts of BIPV was installed in Australia. That's a huge difference in comparison to rooftop mounted PV. And for those products, they're very small in size. Although in recent years, I mean, from last year to this year, I do know there are some larger projects to be developed and some interesting designs to the building facade. Again, it's culture change. And however, we do understand there are also a lot of hurdles for large uptake. Next, please. So to understand the complexity for BIPV product design, we looked into the different parameters which can impact the design, because different from rooftop PV design, for BIPV it is a building envelope material element. If you consider that as a prefabricated element, we not only need to ensure the maximum energy generation as much as possible, but also considering the performance of the product. Also, we need to understand the relevant regulations in relation to where you use the product in terms of building class and in terms of the building element, whether you want to use that as a window or whether you want to use that as a cladding material. Apparently, the building regulations are different. Not only that, but also in terms of the construction process, what's the integration system to the main structure that would impact the following steps in the construction in a building development stages. Next, please. So thereby, back to 2 years ago, we started to map it out according to the different factors we need to consider for a BIPV project. We map it out against the popular PV design software and also the popular building design software, and say that, okay, whether those software or tools can help us to really look into the BIPV aspect. It's not a surprise, but basically our main finding is that none of the existing tools or software platform really designed for BIPV specific. There are a lot of issues in relation to that. For example, some PV specific software really cannot allow PV panels to be used on the building facade. Even they allow, then they don't really have the BIPV database related to that. It's similar to the building side. Of course, you can create your own digital product, etc., but that's fairly complicated. And only certain building professionals can use that. It's quite time consuming. And on the other hand, if the PV manufacturer or distributor, they want to demonstrate the value of their product, it's very hard for them to do so. Thereby, we propose some improvements. Next, Camilla, please. Thereby, we propose some improvements, such as in relation to information, we think definitely we should establish database for BIPV products, including not only the PV site parameter, but also the building required parameters or performance. And we also need to enable the whole procedure for decision making, including some building related, the cost information, for example, for installation and labor, etc. But those ones are very hard for the PV sector to know. And also we provide the localized, say, the electrical side price feed-in tariff, because a lot of, or majority, let's say majority, BIPV manufacturers are overseas. And if we provide a packaged platform to reduce the effort from their sides and to demonstrate the value, that's good. In the meanwhile, building professionals can get more information about the BIPV product and help them to do the design easily. And for the simulation and assessment, we try to make it more professional, to specific. It's like a building envelope design, so that you could place the PV panels wherever you want and replace building envelope. And we want to facilitate the optimization design process for decision making. Next, please. Of course, based in one platform, we don't intend to solve all of the issues we have mentioned or we pointed out. The reason behind that is that BIPV currently in Australia hasn't been used a lot. And the critical part for BIPV adoption is that the building owners, developers, and architects, they need to accept this concept in the very early design stage instead of to the detailed design stage. Otherwise, it's too late because the capital cost of BIPV is much significant than the rooftop PV if you consider the, of course, you bring benefit to offset the conventional building material. However, the early decision making is very important for the building industry. That's why within the current platform we have developed, we want to provide a user-friendly platform and easy procedure that integrates product regulation, technical, economic, and construction data to create a leading BIPV solution. Next, please. So here's the framework of our platform. As you can see on the top, we created a BIPV product database. Actually, within our whole database, we have more than 140 products. However, in the platform, depending on which version you select, the number vary because of some confidential information, etc. And we also have our standard database, which we try to provide some building-related standard information, or at least understand what are the requirements. And we build up the wider database based on the data collected from BOM, and we build up the financial information database that includes the localized some rates or energy price, etc., and as well as the cost, the construction related cost. By collaborating with leading quantity surveying companies. And we allow our user to build up the 3D building models within our platform and do the energy simulation in terms of solar ratings, in terms of shading loads in the urban environment, and consider that to generate DC and AC outputs from that. And they will allow a lot of flexibilities for them to do cost-benefit analysis, environmental related parameter analysis, and we give options for them to select different versions, whether they want to do automatic optimization, help them to do decision making or not. But anyway, the output we will provide in the platform is about the BIPV design in 3D format, and energy output, economic, environmental side, some product information depending on what you want, and the wind load performance and installation and maintenance. And we even provide a small app related to VR to facilitate the visualization process. Next, please. Okay, come back to the standard, because I do understand that that's the main concern in the industry. There, as I said, there's no BIPV specific standard in Australia. So what we did is that we try to understand, okay, based on the very basic requirements in NCC in Australia, what are the requirements for building envelope elements, so that would inform our product information collection process. Of course, not only NCC, but also in some cases, when we look into a specific aspect, we look into the AS standard. For example, for the wind load, we look into the AS 11770 embedded into our software. Next, please. Let's have a look at what product information we have collected. There are different aspects: general, system, electrical, cost, and standards. Next, please. In relation to general, there are manufacturing information such as name and distributor name, location. Some people even provided technical drawing. And some building information related to where your product can be used. For example, your product is a roof tile product or roof shades product. It's about the application element and what kind of building your product can be used. Next, please. Okay. And in relation to the system, we collect the cell-related information, what technology, the color efficiency, and we also collect module information, module efficiency, the thickness, the frame of the module, the material related to the module, and the weight as well. We also collect thermal related information such as U value, HSJC value, acoustic related, and optical related information, as well as the integration methods for that. Say the method, or some even provided the images or video to show that how to install their product. Next, please. And electrical related information, nominal power, maximum power outage, etc. And junction box and wiring and cabling related information, again, important for the electrical engineers to understand that. And losses, again, we collected some information related to losses and the age. Next, please. And cost, we collected per unit cost, rough installation cost, transportation, maintenance, And we also, in some cases, ask for insurance cost roughly. But I need to tell this is only indicative cost information from the suppliers. Of course, based on different products, you might engage detailed negotiation, as we all can understand. And warranty related information, it's important for building professionals to understand. And standard and regulation, we ask for certificates, what certificates they got, and such as the, say, structural loads related information, fire class, what standards they can meet, the category of that, and water tightness, for example. Next, please. Okay, so based in our database, we cover all of the application elements on the building envelope with BIPV products, as you can see. So from the different elements of roof tile, roof shades, to the facade elements, and to the the shading and bolting related elements. Next, please. And in terms of the different building classes, they could be used in cover all of the building, or most of the building classes. Next, please. And the module technology, we cover majority of the technologies in our database, especially those ones ready. I mean, they're popular in the market. And the module transparency, we have opaque module, translucent, and semi-transparent modules as well. Next. Color, so apart from black and blue, there are also alternative colors for you to consider, especially building professionals, to consider and select. And the patterns, it means that some modules, they actually have certain pattern, or for example, look like a stone or timber material on their PV surface. So there are some products like that. Next, please. So in terms of the user workflow, I gave you a very high level user workflow because otherwise we don't have enough time. So when you start, you create a building, you select what kind of building type you want to create, and you can establish the building model within our software, but we can provide options for you to import your simplified lightweight IFC model. That's an option. And then you need to select your role as a building professional or BIPV professional. The idea here is that we assume building professionals know more about the building requirements. They might have very detailed requirements on that. But BIPV professional, we expect that they set a lot of default value basically. And then you select some building information you want to put in orientation, location, and the building environment information. Then the whole building model is there. And then you select the building surface where you want to put the PV, and give a duration you want us to do the solar irradiation simulation. So the platform would do that and generate and visualize the solar exposure from that in the urban environment. Next, please. And after that, you select BIPV application type, BIPV color transparent. It's all about your preference and what product. Say PV manufacturers, you can select your own product. And then you set up some calculation parameters. Then you have two options according to different versions of our platform. You can purely do the simulation by yourself, and we generate the results as what you prefer to say. And alternatively, there's an optimization module in one version. We could help you to generate the results. But no matter what version you do, we also do wind load calculation to tell you. And again, you have options for the VR part. Next, please. Okay, let's have a look at the demo video we generated for you. I think maybe that's the most important, interesting part in today's event. So here, because we understand there are participants from the building sector and PV sector, here we just make a simple demonstration because of the time constraints. And we want to show you that the major procedure. So you can create product, whether existing one or renovated one, select building type. And the next one will allow you to select the location of the building. So you can either put in the exact location as you want, or you can select from the map. You can type in a location in Australia, as long as in Australia, you type that in, and we would help you to identify the exact location of that building or that location, and put that information into our background. Then the weather information by default, we use the BOM related to the nearest weather station, but you can put in your own. And then you generate the entire site you want to create. Then you start with the 3D process. So you can select building within different shapes. There are some predefined, or you can design by yourself. You will see that shortly. Say, for example, this one is a pre-designed, but of course you can change the dimension of the building, not very hard. And you will see that, and you can move around the building and change the orientation and the location within your created site boundary of that. You will see that shortly, I believe. Pam, the video is not playing. Okay. You can move it, as you can see. You can change the orientation. Of course, you can create a building if you want, if you have architectural background. And for example, here shortly we will show you that you can create a base of the building and then add walls to the building. So you can choose different basic shapes of that as well. It's most likely like a typical building design software. However, if you have a lot of building design experience, you can generate more complicated building design. But for a lot of users, I believe, especially for conceptual design stage, you don't need to create very detailed design. You just create the demonstration of the building envelope and the neighborhood, as you can see, to help you to simulate the solar gradient. And after that, you select a surface as we highlighted, and you select a start date time and end date time. For this demonstration, we only did that for a day because we also want to indicate how long it would take for the whole procedure. As you would notice at the bottom of the screen, you would notice our time. Actually, the whole thing, we created that within about less 1 hour to 2 hours. However, we spent some time to really decide which one to capture. So the real time for the whole thing up until the finish is much less than this. But we do want to let you know that for the solar reading simulation, the more you select duration, the more time it will take. Then, as you can see, you selected application type where you want to use BIPV. You can select other parameters if you want. Then the database would tell you what are the available products, and then you can choose the calculation parameters for a lot of economic related parameter and even the environmental related parameter. You can import the energy consumption data as what we have shown just now, or you can ask the system to choose the default energy demand data. If you don't know that, we will decide that based on the building class. So the result is generated for you, as you can see here. The default option here is that we generate the result, make the design in parallel with the building surface design. As you can see here, on this surface, we selected cladding material, and within the automatic generation, they make it in parallel with the surface. And if we remove the solar irradiation visibility, then you see the PV panels are all selected, but only put on where has high solar irradiance area with your selected BIPV digital product. And you can actually remove, add the panels as you wish on the surface wherever you want to do, or you can go to the automatic placement and delete the panels if you want. But there are different options for this as you wish. And you could save your results into your local computer. And of course, here actually we didn't demonstrate, but you can select what product information you want to say in the report or the results in the report. But I need to tell not all the information we collected can be released, but there are alternatives for you to get more, which we will talk in the physical test session. And you could do the wind load assessment, although this part is not recommended for PV professionals, but building professionals, if you want, you can do this. Because there are a lot of cases we can provide the wind load resistance level of the PV panel, and then you can just do a quick check and see whether the product can be used in this situation in terms of the location and the height, etc. And we give you option, as I said, to do optimization depending on the parameter you want to say and the performance parameter you want to compare, which I will show you the results on my slide shortly, because there are a lot of things can be shown. And I believe there's a little bit demonstration here regarding whether you could move the PV panel or not, and whether you could add that or not. And after that, you can import that as an IFC file. And you can export that as an IFC file and import to our VR app. And you can see the design of this building from there if you wish to, but I believe this is the last action if you want to select as an option here. Let's move to the next slide. So as you can see, we provide options to demonstrate the optimization process. The idea behind that is we based on all information we collected and based on what you tell in the system about the performance criteria, constraints, and design variables, we provide you different alternatives. Next, please. For example, those two case studies we have done as test case is that one is for ring screen facade, case 1, and the second one is for the roof shades and skylights. Next, please. Say for case 1, for example, we look into whether the PV should be used on which surface of the building, the 3 directions we select, east, west, north, and what objective you want to achieve, whether you want to maximize PV generation or life cycle cost, and we gave some constraints. And we selected 16 products for the comparison, and actually, as you can see, with the combination, there are more than 200,000 cases. However, with our algorithm, it can tell you the results very soon. Next one, please. It's similar for the second case for the roof shades with different combination with 16 products. We get a lot of options. Next. And skylight less because we selected less PV products in this case. But again, it's still a lot for manual comparison. Next, please. So our software can tell you in terms of different case and the design optimum design options. It doesn't mean that we give you one solution, we give you options. Ask you to select from the options, but we ensure that those options are the best ones within the whole cohort or the whole scenario, possible scenarios. And we can give you the POA radiation and life cycle energy output, energy, and the economic analysis, and we demonstrate that actually we optimize the option. Next, please. And a typical thing is that there are, for one case, we could say this one, we give you 12 options. We tell you, but those 12 are the best within the several thousands. And we say that, okay, you might consider to put PV panel on this surface or on that surface with what tilt angle and what product you could consider. Next. But in relation to the different options, as you can see, the performance is different in terms of the life cycle cost and life cycle energy. We also can show you that the different options with different outputs. Some people may look into, oh, I care more about life cycle cost, but the other one want to see the balance solution. So that would give you different decision options to facilitate you, especially building professionals, to convince the building or talk with the building owners about the option and make the right decision there. Next, please. So we can demonstrate the design, a more complicated design. Next. Okay, so that's basically all what I want to mention related to our platform within this time frame. But what's next? We do want to get some feedback from you, and you will get a follow-up email from BIPV to inform this. And if you wish to participate, please let us know. Especially we organize upcoming physical trials in major cities to really use our platform, but of course, depending on COVID restrictions. And we are very interested in BIPV product design modeling assessment. If you have any interest, you can always talk to us. You don't have to use our software or platform. We could do that. Oh, don't go back to the last one. And we are interested in BIPV standardization, and we do research projects related to this and try to push the industry change. We're also interested in trial projects, so testing lab and product testing, performance certification, etc., and policy decision making. Thank you. That's all, Pamela. If we go to the last one, whenever if there's any question for future, please contact me. Thank you.
Hi, sorry, Rebecca. Thanks for everything. I think you might need to mute. We're all good. That was really interesting. Thank you for your presentation. It seems like it will save us a lot of time doing the design of and selecting the BIPV products. So really, really good effort. Great work. Just gonna go ahead on the next slide. So thank you everyone and Rebecca and her team for coming along to this presentation. Just one last point. This event, you're eligible to claim some GVCA CPD points. If anyone is interested, you just have to show your ticket to the GVCA to claim the point. And I'll stop sharing my screen so I can see if there's any questions from the audience. We have the I have some. First question for you, Rebecca. Does the product database include both Australian and international products?
Yes, there are. Majority of them are manufactured. No, we cannot say that. But the firms, majority of them are overseas. We do have Australian-based firms, including distributors. And there are more people actually contact us and hope to have their product to be included.
Amazing. Next one we got, thank you for the presentation. As BIPV can be located within components that form part of thermal envelope, for example, external spandrel, how good is the integration of BIPV panels with insulation requirement that the external facade needs to achieve? That's one part of the question. Do you want to answer that one, or I continue with the other part?
I can say the question. It's a very good question, actually, because there are a lot of concerns about this part. That's why we collected information about the integration system to the building structure, no matter where you want to use that, as well as the thermal performance of that product. Of course, if you consider as maybe a cladding material, there's not much change, but if you not much importance. But if you consider there's a curtain wall, then that's another story. We do compare that with NCC, but we don't make decisions based on that. I think we just provide that relevant information. If you are a building professional, you make decision by yourself because we think we provide sufficient information to facilitate your decision making regarding whether this product is appropriate or not. And in relation to your second question for the I believe it's details the details of that. Globally, we actually collect a lot of BIPV building design drawings. Although they're very confidential, we could not release those information, but there are a lot of examples can provide good insulation and thermal comfort to the buildings. I hope that answered your question.
Amazing. We have another one. What is the process of accessing the BIPV Enabler?
The process, we haven't really announced that yet because our project hasn't completed. We do welcome any feedback and suggestions so that when we do the physical trial versions, we could again collect more feedback. But eventually, our plan is that we would make it as a commercialized platform because that's the funding scheme from ARENA. And the details for that, we haven't really formalized, but we will keep all of you informed in the near future on that. But the whole purpose is not about the profit from that. It's about to enable BIPV application in the industry. We can provide trial versions for interested industry partners.
Don't think anything more. Maybe this one hasn't been answered yet. How accurate is the energy estimation from the model compared to the real life scenario?
It's hard to really tell you the accuracy rate, but what we have done is that we, apart from what we demonstrated here, we also did global studies through IEA PVPS collaboration to really understand that what's the best method to do energy generation estimation. And we did a global survey actually in relation to that. We haven't really published the results, that's why we didn't mention. However, the idea is that we use the most popular method in our platform and try to enhance the accuracy based on the solar irradiance simulation, etc. But of course, we all understand the real situation would always be different from the design. That's a typical issue in not only in BIPV, but we tried our best to increase the accuracy.
Yeah, no, definitely. I think that these all the questions that we have from the public. Does anyone else have any questions they would like to bring at this point? You can raise your hand, write it down. I think we might finish early.
I got some direct messages
Okay.
from the audience. One is about, is the program used for today's webinar available? As I said, we will provide the trial session to all of you. It's not published on our website yet, but we intend to publish that in the near future. And in terms of the interest, he also put another question about how to register the interest to be part of the trial session. And I believe Camila and Ebipsa would help us to send out a follow-up email to all the participants, and you will get the information from there.
Yeah, that's right. We'll follow up with an email for everyone.
That's all what I got.
That's all. Okay, we got a comment here from Danielle. Thank you, very informative and bringing large data sets together with constructability included. So great job. Oh, good. Well, it seems we're finishing up early. Thank you, everyone. Thank you, Dr. Yang and your team. It was great, very informative.
Thank you all.
Thanks, everyone.
Thank you.